This concept is that of a rotating mirror. So here is shown a mirror and the angle of incidence is I and the angle of reflection is R, which is equal to I according to the laws of reflection. This happens to be the normal, this happens to be the incident ray, and this happens to be the reflected ray. Now let us understand what will happen if we try to rotate the mirror. Let us say if the mirror were to be rotated by an angle theta, and hence the mirror now becomes like so. So it is rotated by an angle theta. So this is the new position of the mirror, and this right over here is the angle theta. So as a natural consequence, since the normal is always 90 degree with respect to the mirror, the normal will also get rotated by the same angle theta. So normal will get rotated like so. Now we can see that the new angle of incidence is going to be I minus theta, I minus theta, and thus the new angle of reflection is also going to be I minus theta, which now is the same as R minus theta. So if I draw a reflected ray, it will go somewhat like this, and the angle of reflection is going to be equal to I minus theta as well. But since I is equal to R, this angle of reflection can also be written as R minus theta. So we can see from this diagram that this was the original normal, this is the new normal, this was the original reflected ray, and this is the new reflected ray. So compared to the original reflected ray, how much is this shift? If we were to calculate this particular shift, let me call that shift as alpha. Let's say this shift is alpha. We can say that this original angle, this angle was essentially 2i, because it is I plus R, which is I plus I, hence it is 2i. Now in order to find out the angular shift alpha, we need to find out this particular angle. Okay, so let's say this angle. So this angle we know is 2 times I minus theta. So visually we can understand that 2i consists of 2 times I minus theta plus alpha. So from this equation it is very apparent that alpha is equal to 2 times theta. So the shift, or the angular shift to be precise, that the reflected ray experiences happens to be 2 theta. Now same is true even if the mirror were to be rotated in the clockwise sense rather than the anti-clockwise sense. Let's examine that particular possibility. So this is our original diagram. Now let's try to rotate the mirror in the clockwise sense. So the mirror is now rotated clockwise, and again it is rotated by an angle theta. So this angle happens to be theta. Alright, this is the angle of incidence I, this is the angle of reflection R, but I am drawing it as I only right now because we know that I is equal to R. Alright, so now what will happen is angle of incidence, or the incident ray, remains the same. The reflected ray is going to get rotated. let us first draw the rotated normal. So the rotated normal will be perpendicular to the new position of the mirror. So let's say this is the normal. Now since the mirror itself is getting rotated by an angle theta, this normal also rotates by an angle theta. So now the new angle of incidence we can see is I plus theta. Similarly, the new angle of reflection also is going to be, let us say this is the new angle of reflection. The new angle of reflection is also going to be nothing but I plus theta. Now compared to the original, how much has the new reflected ray shifted? So let us say the shift is given by an angle alpha. Thus, we can now figure out what is the angle alpha from the angular geometry of the situation. So earlier, as we know, this particular angle was 2i. Now we know that this particular angle is 2 times I plus theta. So we can now visually understand that 2 times I plus theta happens to be equal to 2i plus alpha. Therefore, again, alpha happens to be equal to 2 theta. So no matter in what sense, clockwise or anti-clockwise, the mirror rotates. If the mirror is rotating by an angle theta, then the reflected ray is rotating by an angle 2 theta. This is important to understand. Now let us say we differentiate this equation, then we get d alpha by dt, the rate at which reflected ray is rotating, or also it can be termed as the angular velocity of the reflected ray. So this is equal to 2 times d theta by dt. So that means omega of reflected ray, omega is the symbol that we typically use for angular velocity, omega of the reflected ray happens to be equal to 2 times omega of the mirror. So I'll write this equation again clearly. Omega of the reflected ray happens to be equal to 2 times the omega of the mirror. So this is one conclusion that we have to remember.